Welcome to qnawire.
Okay, here we're given an apparatus. It's attached on the left and it's rotating at 9 radians per second. We have some geometry for it. We want to find the angular velocity of this segment AB. If B is confined to move in a horizontal direction, at this point A will be moving in a vertical direction. I just realized I wrote the wrong direction here for omega here. The velocity direction, other velocity directions are correct, but this will be rotating in a counterclockwise direction over on the left there. Point C is the center of rotation for this device. So first we can calculate the velocity of A, which will very simply just be the length OA times the omega for OA, which was the 9 radians per second, times 80 millimeters, which will give us about 0.72 meters per second, or 720 millimeters per second, depending on what you're comfortable with. Next, we can use the triangle ABC to calculate the length between points A and C on that triangle. So that length AC will equal the length AB times the cosine of the angle, which is 30 degrees. The length AB is 200 millimeters total. So we get about 173.2 millimeters for that length AC. You could also use the Pythagorean theorem to find that length. And I should note that we get this 30-degree angle here because in a 30, 60, 90 triangle, the length of the side opposite the 30 degrees will be exactly half the hypotenuse, which is what we have here. So then we can calculate the angular velocity of this link AB here. So omega AB will equal the velocity of A divided by the length AC. We know what the velocity of A is, and we know the length AC. The velocity of A was 0.72 meters per second. The length AC was 0.1732 meters per second. So we end up with about 4.16 radians per second, and we need to choose a direction for that. This will be in the clockwise direction. So I'll just highlight that in green here, going around C. So after we have that omega, we can calculate the distance between point B and C, which is just 100 millimeters because that was given to us, so we don't actually have to calculate that here. Then we can find the velocity of point B. So I'll switch to red here, the velocity of point B. Will just be that length BC times that omega that we found, omega AB here. The length BC is 100 millimeters. The the distance, or sorry, the velocity, the angular velocity was 4.16 radians per second. So this gives us a velocity then of about 0.416 meters per second, and it's confined to move in that horizontal direction to the right. So the next thing we need to do is a little bit more complicated, is to figure out the velocity of point G. But to do that, we'll have to find this length GC. And to do that, we're going to have to look at a little bit more geometry here and apply the law of sines. So if we go ahead and redraw our triangle here, so I'm going to draw this in green. We'll have point G, we'll have point B, and we'll have point C. And this is the triangle we have shown up here. But we can add a horizontal line in here to make our work a little bit simpler. So we have a right angle there, right angle there. We know this angle is 60 degrees, and then this angle has to be 30 degrees. But we don't know these other two angles yet, so I'm going to call them theta 1 and theta 2. And we can find these by looking at the law of sines. So if we take the sine of 60 degrees over CG, so the length CG, which we don't know yet, that has to equal the sine of theta 1. So I drew my angles a little bit incorrectly. So instead of theta 1 just being the lower part of this triangle, I wanted theta 1 to be that entire angle. And theta 2 is drawn correctly then. So theta 1 divided by the opposite side, which is BC, which we already know the length BC is 0.1 meter or 100 millimeters. So I'll just write that in here. Then that has to equal sine of theta 2 divided by the length BG, which we know is 100 millimeters as well. So that implies that theta 1 and theta 2 have to be the same angle. The only way they can be the same angle if our other angle is 60 degrees is to take what's left over after that 60-degree angle. So we have 180 degrees minus 2 times theta 1 equals would have to equal 0. I forgot an angle here, 180 degrees minus theta 1 minus theta 2, but those are the same, so that's where the 2 theta 1 comes in, minus the 60 degrees has to equal 0. So that implies then that theta 1 equals theta 2, which is just 60 degrees. If those angles are all the same, then the lengths are all the same. So then CG, that distance, must be that 100 millimeters as well. So once we know that length, we can go ahead and figure out what the velocity at G is pretty simply. V at G will just be that omega on that bar, so that's omega AB times that length CG that we already found. So this would just be 0.416 meters per second again. Then if we want to figure out the angle that the velocity of the center of gravity of the rod makes with AB, so that would be this angle right here. We would just need to look at how far it's rotated. This angle is rotated, which would end up being just 30 degrees if we carefully look at this.